All right, today we are talking about lines of best fits for a scatter plot. We talked about a scatter plot, and I'm going to do examples down here. We're going to do 3 examples. We talked about a scatter plot being a graph where it compares two quantities. So the quantities are numbers, and we're graphing these quantities or variables, one along the x-axis and the other along the y-axis. Okay, so an example could be you could have hours worked, use this example yesterday, hours worked and total income. Hours worked and total income. Those are two quantities, and you can graph that on a coordinate plane. When you graph and your ordered pairs, for the most part, are going up, this is a positive correlation. Another type of scatter plot, and I'm going to put positive correlation under it. And we talked about this yesterday. When you have a scatter plot and the points are going down, this type of relationship is a negative correlation. So example, that could be hours traveled, miles traveled, and the total gallons of gas in the tank. So the more you drive, the less gas you're going to have in your tank until, of course, you fill it up, okay? So this is a negative correlation. The last example that we talked about on yesterday is a no correlation. So this is where you have independent variable or quantities that you graph along the x-axis, dependent variable or quantities or a variable that you graph along the y-axis. An example of that could be, we talked about this before, a student's weight and their grade. Your weight and your grade have absolutely nothing to do with each other. That's a no correlation. Weight and grade. That will be an example of a no correlation. Any questions about that? All right, so now that you know all of this, you know the difference between a scatter plot that gives you a positive correlation, negative correlation, or no correlation at all. This is describing a scatter plot. The other thing that you can do with a scatter plot is create a line of best fit or a best fit line or line of fit. So many different ways to say that. I'm going to underline it. It's right here. Okay, zoom in just a little bit. A line of best fit or line of fit is a line that best goes in the blank, describes a scatter plot. This is the one single line that best describes the scatter plot. And later on, we use that line to make predictions. It's super important, especially in research, that you collect data, okay? And you collect this data for a reason so that you can make future predictions. And this is how they do that. They take these two different variables that they want compared, and they make predictions of what the outcome could be by using a line of best fit. All right, so let me keep going. Here, the criteria of a line of best fit. Criteria is this. The line must be going in the same direction as the points or ordered pairs. So if your points are going up, your line has to go up. If your points are going down, your line of best fit has to go down. And if you have a no correlation, then there's no line of best fit for this. There is no line of best fit for a no correlation because the points are scattered everywhere. I'm going to pause for the cause to make sure you understand. The second criteria, number 2, there should be almost the same number of points or ordered pairs above the line as below. That means your line of best fit should be in the center of the data. Your line of best fit should be the center of the data. Now, the calculator you will find will be able to do it perfectly. But our hands and fingers, we're going to get close to the line of best fit as we possibly can. And I'm going to show you how to do that. We're going to do both ways. We're going to do it by hand, and tomorrow we're going to do it in the calculator, which will be a lot easier. All right, so this is how this works. Okay? Remember, you can only do a line of best fit for a positive correlation and a negative correlation. But you can't do a line of best fit for a no correlation because the points are not going up or down. There's no pattern here. And that means the X and the Y variables have no relationship. So it's no point in making a line of best fit. All right, so let's look at the positive correlation. What you do, look, this is how I'm showing you how to find the line of best fit. The first step, pick 2 points. You can just use the number 2. Pick 2 points that form a straight line in the center of the data. So the 2 points that I'm going to choose are going to be 2 points that when I draw a line through them, it's going to be in the center of the data. So I'm going to draw, the center of the data is right in here somewhere. So I'm going to choose 2 points in this area. So this is a point that's in the area, and this is a point that's in that area. So I'm going to draw a line through these two points. So I have 1, 2, 3, 4, 5 points possibly there. 1, 2, 3, 4, 5 points above, give or take a 2, is kind of in the middle. And then again, it's not going to be perfect, guys. It's okay that it's not perfect, but it needs to be really close to the center. And remember, since we're doing this by hand, there's going to be some human error. The calculator could do this much better. Questions about the first step? So far we have a line drawn through 2 points. And those 2 points, when we draw a line through it, that line is in the center of the data. This is a good line of best fit. So now this ordered pair, if I'm using the grid lines, okay, imaginary grid lines here. Okay, imaginary grid lines. Okay. So this ordered pair is 2 and 1. 2 and 1. Actually, yeah, well, let's use the same points I used my last class, just in case they want to watch this video. Let's use 1 and 1. 1 comma 1. We'll use the same points that they used. So 1 and 1. And let's use 5 and 4. We'll use those 2 points. Okay. So now, the second step is we're going to take these 2 ordered pairs and write an equation. So to write an equation, we've already done this before. The first thing you have to do is find the slope. The letter for slope is M. So it's 1 comma 1 and 5 comma 4. And I'm just using these 2 points because these are the same 2 points that I used in my first class. And so if they go back and watch the video, it will be the same. It'll be consistent. All right, so let's find the slope first. The formula for slope, write this out to the side. Let's do slope formula. Is M is equal to Y2 minus Y1 over X2 minus X1. Okay? Excuse me. So now I'm going to take these numbers and substitute it into the formula. This is x1, y1, x2, y2. And on the top, my y2 is 4 minus my y1 is 1. On the bottom, x2 is 5 minus x1 is 1. So on the top, 4 minus 1 gives me 3. Put an equal here. And this gives me 4. So my slope is 3 over 4. Okay. My second step is to find the y-intercept. You see that? Number 2, find the y-intercept. The letter for y-intercept is B. And again, guys, we have done this before. So in order to find the y-intercept, to find B, you are going to use y equals mx plus b. And I'm going to pause so you can kind of catch up and think about it. Okay, so now I'm going to take and I'm going to use one of these points. I'm going to use this one because this seems like the easiest. It doesn't matter which one I use. I'm going to get the same answer either way. But I'm going to take this one because this one is easier than these numbers. And my slope, and plug it into the slope-intercept form and solve for b. So y is 1. M is 3 over 4. And x is 1 plus b. Okay? So to get b, to solve for b, I'm going to multiply this first. So this gives me 1 on this side, bring it down. And here, when I multiply 3/4 times 1, that just gives me 3/4. Bring down the plus b. To get b by itself, I got to get rid of this positive 3/4. So I'm going to subtract 3/4 on both sides. Okay. When I subtract 3/4 on this side, this gives me 1/4 left. Okay. If you don't remember how to subtract fractions, please use your calculator. Don't get this wrong. If you want to write it as a decimal, it's not wrong. You can write it as a decimal. Here, this is gone, and I'm left. This is 0 here. 3/4 minus 3/4 is 0, so I'm left with b. So my b is going to be 1/4. Then that means that my line of best fit, which is written in y equals mx plus b because it's a straight line. This is slope-intercept form. Y is equal to my m, which is 3 over 4. Bring down the x, and my b is 1/4. This is my line of best fit. So I'm going to write the equation of the line. I'm going to go back down here. Just give me a minute. The equation of this line of best fit is y is equal to 3 over 4x plus 1/4. This is my line of best fit for this scatter plot. Okay? And I'm going to go back down here. Okay? So now we're going to do the second scatter plot, and we're going to find the line of best fit. Again, I'm just going to use the same ordered pairs that I use with the other class. Okay? It may be off by just a little bit. So you're going to still do about the same thing and find 2 ordered pairs that if you draw a line, it's going to be in the center. So I'm going to choose this line, maybe this line, this point over here, and maybe this point way up here. Okay, so the 2 points that I chose are going to be 2 and 6. 1, 2, 3, 4. Let's make it 6. 5, 6. And then the other ordered pair that I chose in the last class was 7 and 1. Okay, 7 and 1. So I'm just choosing the same ordered pairs that I chose in my last class. So now after you choose your 2 points, you kind of count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It's almost in the center. Okay. All right, so now you're going to go down here and you're going to use those 2 points to write an equation for that line. So your 2 points, we got 2 comma 6 and 7 comma 1. Remember, it's going to be a negative slope because again the line is going down. So first thing we do is find the slope. Use this slope formula. This is your x coordinate, x1, y1, x2, y2. Your y2 is 1. Minus is a part of the formula. Your y1 is 6. Your x2 is 7. Minus your x1 is 2. So on the top, this is going to give me a negative 5. And on the bottom, this gives me a positive 5. So your m here is going to be a negative 1. And I'll pause real quickly to make sure that you have this copy. All right, let's find b. B is missing. That's the second step. Find b. To find b, you're going to use the slope-intercept form, just as we've talked about, y equals mx plus b. And you're going to pick one of the points. I'm going to choose this one, okay? I'm going to choose 7 and 1. It doesn't matter which one you use because they're on the same line, you're going to get the same y-intercept, okay? So you're going to get the same answer no matter which one you choose. So here my y is 1 equals my m is negative 1 times my x is, my x is 7. I'm tripping. Sorry, y'all. Plus b. So this is going to give me, this is 1 is equal to, we got negative 7 here plus b. So when I get b by itself, I got to add 7 to both sides. Do the opposite of a minus 7, add 7. And this is going to be 8. So b here is 8. So my equation, sorry, let me slide up because it's hard to see that. My equation in slope-intercept form is y is equal to a negative 1. So I can put negative x plus, because it's a positive, 8. So the line of best fit for this equation up here, and I'll go back down, give me a second, is y is equal to negative x plus 8. This is the line of best fit for this scatter plot. And I'll go back down so you can write that in. And I'll pause it here. Okay, so the very next page, we're going to talk about causation and correlation. Very simplistic. Okay, you can describe a scatter plot as being causation. You can also describe the correlation of it. Okay, they are not one and the same, and they're not opposite of each other either. Okay, so let me explain. Causation is the relationship. Okay, is the relationship between cause and effect. So basically, one variable causes the other variable to happen. And it's usually the independent variable causes the dependent variable to happen. An example of causation could be, I'll write this out to the side. You have your scatter plot where you might have your number of calories here, like the calories or that you consume, and maybe your weight gain here. So this could be maybe calories or fat calories, because of course not all calories are bad, right? Fat calories, and then this could be weight gain. And it's a little different for everybody's body type, but on the average, this is going to be the more fat calories you consume, the more weight the more weight gain you're going to have. So this would basically be a positive correlation, but it's also causation as well, because this causes the other to happen. Any questions about that, about causation there? One variable causes the other variable to happen. All right. Correlation, just finished talking about, is the relationship between two quantities or variables. And I use them interchangeably because you may hear one or you may hear the other, but they're basically the same thing in a scatter plot situation. Okay? You might hear X and Y, they might refer to them as quantities because they're both numbers, or you might hear variables because the X represents fat calories or hours or age or whatever, and the Y represent something else as well. So you may hear quantities and you may hear variables. And in this case, you hear two events. So these are all synonyms. They're still talking about the values that you graph on the x-axis and the values that you graph on the y-axis. Any questions about this so far? Now we're going to talk about the correlation coefficient, your R. Your correlation coefficient is represented by the letter R. And basically what R, or the correlation coefficient, remember that word correlation, what we just got finished talking about, the correlation, positive correlation, negative correlation, or no correlation at all. Your correlation coefficient is a number that tells you the strength of that correlation. It tells you how strong it is, okay? And the three words that you're basically going to use is either going to be perfect, well, it's four. Perfect, strong, moderate, or weak. This is telling you the strength of the correlation. So they're going to use numbers to do that. All right. So your correlation coefficient, which is R, is going to be between, is a number between -1 and +1. Anything that's outside of that is not talking about R. R is only between -1 and +1. Okay, it can be -1, it can be +1 as well. But this is what R is talking about. It's not 2, 5, 7. Somebody tell you the correlation coefficient is 7. They are totally lying and don't know what they're talking about. The correlation coefficient is only between -1 and +1. Okay. All right. So now let's talk about what that number means, or what those numbers mean. Your R is between, of course, -1 and +1. And of course, in the middle is 0. And the closer that the numbers get to 0, this is a no correlation. So the closer it gets, absolutely no correlation. Okay. All right. So a strong, we're going to start off with strong. This or perfect. If your R is a -1, then that means it's a perfect line going down, has a negative slope. So it's a perfect straight line. It's a perfect line, and M is positive. M is positive. Let me put that up here. Perfect line. M is positive. Man, this is like this pencil. Just that one. There we go. Okay, M is positive. On this side, if it's a positive, negative. God, so Jesus. Sorry, Lord. It's a negative. Over here, if it's a +1, perfect straight line. But the slope here is going to be a positive. So -1, perfect straight line. The points form a perfect straight line, and it's negative. Over here, the points form a perfect straight line, but the slope is positive. The line is going up here, the line is going down here, and they're perfect straight lines. A strong correlation, that means the points are kind of spread it more further apart a little bit, but it's still a strong correlation. But it's not a perfect straight line, but it's a strong correlation. It's going to be here between -1 and possibly a -0.75. So somewhere in here is a strong negative. Okay? And on this side, positive 0.75, this is going to be, these numbers in here are going to be a strong positive. So those points are kind of still close together, but they're not a straight line. This is still a strong correlation. And it'll probably make more sense to you when we start doing these in the calculator. Now in the middle, on this side, let's find the middle mark. This is -0.5 over here. The numbers that are here in the middle here are moderate. This is going to be a moderate negative correlation. And on this side, positive 0.5. The numbers that are here in between here are going to be a moderate positive. And lastly, anything that's in here is going to be a weak to a no correlation. If it's 0.1 something, Joker, that's going to be a no correlation. Almost anything in here is going to be weak or no correlation, because even a 0.4, depending on what it is, it's going to be a no correlation. But sometimes they say it's weak. So we got weak to no correlation in here. Very, very weak. Very, very weak. And I'm going to pause here. We'll wait till tomorrow. Make sure I put this part in the video. We'll wait till tomorrow to submit this, okay? Now we're going to look at the independent practice. I only want you to do the following today. I only want you to graph. Everything else we are going to do together. So please only graph the ordered pairs for each of these examples, and there are 4 examples. So all you're going to do is do this part right here where you're just graphing them. So I'm going to show you how to graph the first one. And guys, we probably already know how to graph. We got to create an x-axis and a y-axis. I'm going to label my x-axis down here, which is the study hours. Okay. And it's going from 0 to 5. So from 0 to 5, this is 0 here. 1, 2, 3, 4, 5. Or you can skip lines if you wanted to. If you want the graph to be spaced out a little bit more, you can put 0.51, then 1.52, 2.53, 3.54, 4.55. You can spread it out a little bit more if you want to. And it might be better for you to spread it out so you can see your points better. And then here, your Y is your grade. So we put Y here. And I'm going to put grade. Okay. So my grade is going from, the lowest grade is 70. And the highest grade is 92. So I'm going to do what you call a break in the line, where I'm going to start at a certain number, and then from there I'm going to go up by the same number of increments. So since my lowest number is a 70, I'm just going to start at a 70. And I could probably, if I go up by 2, I'm not going to make it. So let's go up by 5. So this would be 75, 80, 85, 90, 95, 100. That's plenty of space. And then you can take your ordered pairs here and just graph them. So all you are doing in these examples, and it's 4 examples, is you're just doing the graphs only today. Everything else we're going to do in the calculator tomorrow. Questions, comments, or concerns? Okay, I'm going to go ahead and stop the video.